Yep. Okay. So hi everybody. Hi people on YouTube watching us. So welcome to this 11th community call, Madara community call. So what's on the program? I will share my screen. Up. So not a lot of thing. What happened is that last 2 weeks we did like the second sprint. So it was still about bug fixing, improving the code base test coverage, and it actually worked well. We discovered a few new bugs by rewriting the test we have in Rust. The strongly typed system forces us to test all the fields we receive in a way more complete way than we were doing it with just JavaScript, and this led to some new bugs being discovered. And I will say a few words about the things I have been working on for the past weeks now, maybe 1 month on the repository, which is like the transaction type refactoring. And then Approve will do a presentation of the Madara app chain template, which is an initiative that will make it much more easier for other projects to use Madara in order to run their own app chain. Because right now they have to fork our repository, which is not a good way to do. So I will tell you more about this. So about this, the past sprint, the core team was focusing on end-to-end testing. So we did some of them. Some of them were done, and we have more contributor willing to help. So we have Patrice. I forgot your full name. I think it's Thomas, another French guy, and people start to pick some. So we are getting somewhere with this. Lana started to do like one example of this optimize encoding and decoding. So right now in the runtime, each time we read from the storage, we use the parity scale codec algorithm to encode, decode the storage content. So we spend a lot of time doing this. So if it can be optimized, it will be great. So there is an initiative to do this, and it will have to be done like between different repository we depend on, namely KeroRS, StarkNet API, the Blockifier. So Lana started to do one of them, and then some other contributor will be able to hopefully do the same for the others. And we had some improvement on the CI, and this one that we thought were a bug and actually wasn't, which is basically that we started with a negative felt, and when we get it back from the storage, it turned out to a positive number, but it was just like the felt wrapping around because there is no actual negative number in the Kero virtual machine. It's just that you can interpret them as negative number. So that was it. And for the issues that have been done by the community, so we added basically all of those were added 2 weeks ago, and most of them has been picked. A few of them has been fixed. A really nice one was this one that Michael did, which was about event ordering. Basically, when you had smart contract calling other smart contract and both of them emitting event, we weren't re-emitting the event in the correct order. So it could have led to some bugs and strange behavior. So this one was fixed, and we still have people working on other one. So hopefully it will be finished this week. And I added a few new one, but they are still there to be picked. About the next sprint, well, we will continue with the same thing, so this won't change. We still need our end-to-end Rust test, and hopefully we will find out some bugs, some new bugs again. And what's coming next is the data availability logic. So Ben is working on a pull request which will merge the data availability logic from Avail, Ethereum, and the last one is, I forgot the name, a chain which does data availability. It's
Celestia.
Celestia.
Yes, Celestia, thank you. So the thing is, the logic between those three are different, but they can all fall under the same API, the same interface. So the initiative Ben is leading is to have like one single pull request being merged in the repository, offering a unique interface for user to choose where they want to commit their data. And once we have this, we will have to start thinking about layer one, layer two communication. We have some logic already in order to fetch messages from layer one, but I don't think it has ever been tested in an actual setup with an Ethereum network running and a Madara chain running at the same time and communicating. So in theory, it should work. In practice, I'm a bit doubtful. So I think in the next week, so this sprint or the next one, once we are done with the test and also the huge type refactoring, we can focus on this track. And after that, we will start to be more or less production ready. Maybe not totally, but it will be a huge step forward. And yeah, that's it. Is there some question? Did you guys and girls add things to talk about before we go to like me talking about the type refactoring and approve about the app chain tooling?
Actually, I would have one question. So this is my first community call. And I was wondering, are all the issues for the roadmap for the core team in the same backlog as the one open to the community, or is there two different backlogs?
Well, there is like those two views on the Madara project. The idea is that this one, like the sprint, the idea was to try something where people picking stuff in the core sprint would like commit to a deadline to finish it and work full time on it. Like the core team is supposed to be people working full time on it, while there is this other backlog, which is more like side improvement and bug fix and new features that can be done in a parallel way. In practice, now people from the core team have been helping with those, and we have contributors also helping with this one. So I would say it's not as well defined as we would like it to be. So no, don't worry too much about this. You picked you said you will be working on this one. So yeah, it's in the core sprint, but it can be split on multiple smaller tasks. So no worries with that.
Oh yeah, for sure. No, I was just wondering if like all the issues were public and accessible to anyone.
All the issues are public. There is no like another hidden backlog. Like everything is there.
Okay, very cool.
It's more that for people who are working full time on the project, we try to have them focus on like the core thing we want to move forward for the next week. And for all the other things, it doesn't matter as much if somebody pick it and don't have it finished 2 weeks later, which is what has been happening with everything you see in the in progress column. Like, yeah, it's not finished for the end of the sprint. yeah, that's life. It's not
Okay.
really important. It will be better if it was, but that's life. People have their own agenda and they are not committed full time to the project. So we do what we can with it. Okay. So yeah, maybe we can also talk a little bit about substrate repository being moved into another repository named Polkadot SDK. I don't know if you saw that. So hopefully it won't have like many implications for us. The code is still there. We can still use it. But in terms of like branding, it's a little change. That was the little news around the project. And well, let's go to the, how can I have this bar. Okay, oh yeah, we have the backlog there which is built from all the issues. So we can see there is a lot of fixes, a bunch of dependency upgrade, a few new features, but it was, like we said, for the first sprint, it will be a code freeze mainly, and a lot of improvement on the CI and on the test and fixing bug. And good job to our 4 new contributors. Bravo to them. And so my point was about the transaction type refactoring. So I have this pull request, which is a behemoth of a pull request. I'm sorry about it. Basically, what I did, the way it was working before this is that we have the RPC type for the transaction. And then in the RPC, we create a new object, a new transaction type, which will, in theory, be sent to the runtime. And then the runtime, we will convert it to like the blockifier type for transactions that will take care of the execution. And the problem is that we didn't have like one single intermediary tip. We had 2 of them, and we spent a lot of time going from the first to the second, then to from the second to the first. There were like maybe 3 or 4 back and forth, which was just like pointless type conversion, because some functions were implemented in one type and not in the other, and people started to convert in order to access the other functions they needed. So it created a lot of useless computation and makes the code less readable. So what I did is I went for this new design where we have like the RPC type, our type, and then the blockifier type. And we just do like the conversion. And so I put those in primitives, transaction. And if I go to the mod, yep. I just basically recreated like all of those types. So we have user invoke transaction with the different variants. And we have our custom type inside. So this one, we have full control on it. We can do whatever we want. And we convert from the API one to this one, and then to the blockifier one. And there is like 2 wrapper, which are those one, like user transaction, which are transactions that has been created by users. And the whole transaction, we can be like any transaction, and depending on what you are doing exactly in different part of the code base, you will want to match on one or the other. And then I implemented like a bunch of getters, the logic to do a conversion. So to convert it to executable, so to the blockifier type, we have to do like to compute the hash, to compute some stuff. And then we have this structure, and we can execute it. There is also in the other side, so from the type to the RPC one, and the logic to compute the hash of each transaction. I fixed something in the implementation that I think weren't like exactly what it should be. And the problem is that this type were used basically everywhere in the interface we have between the runtime and the client, in the block. So once you change this type, you have to go through like the whole code base in order to put everything at the new type, using the new type. So it's ended up having like a lot of file being changed. So if anybody wants, he can review it. The current state is that it compiled, it run, but I don't know if it works because the tests are broken right now. So I'm doing like the type conversion in the test file right now. And once this is done, we will be able to run the test and see that I probably broke a bunch of things. But my take on this one is that I spent like many hours, many weeks on it, and I was a little bit tunneling on it without much feedback from outside. So, and it will be like a huge thing to be merged in the code base. So I would really appreciate if some of you guys and girls can do a review on it, like an intensive review, asking all the question when there is stuff you don't understand, you want to add like some documentation, some code on different parts, and challenging the implementation choice I did also. I would it will be like a good time to do this now, because it hopefully will be merged in during the next sprint, so next week, or this week or next week. I hope so. So yeah, please go ahead. It's a simplified text type draft pull request. Give it a look, and be as harsh as am I when I review your pull request. It's your time to give me like a taste of my own medicine. So please review it hard. And is there any question on this? No? Okay, so let's go with approve if you want to proceed to your demo.
Yeah, I'll do that. I'll just share my screen. Can you see my screen?
Yep.
Okay. So I'll just probably move this here. Yeah, so basically the idea of the app chain template is to allow anyone who wants to make app chains from Madara to be able to do it in an easy way and remain updated with Madara as well. So before this, the only way to make app chains from Madara was to fork the repo. You fork the repo and you make whatever changes you want in the files that you want to. And whenever Madara has new changes, you rebase Madara. And if you made changes like in the places where Madara had changes as well, like you'll have a lot of conflicts and everything. So basically what ends up happening is that you fork the main Madara repo, you make your changes where you want to change, and you keep rebasing with time to remain updated. So this wasn't the ideal approach. So basically what we decided is that we will take an approach that Substrate allows us to do. So Substrate has this thing called palettes, which basically makes it very easy for you to, like import certain functionalities into your blockchain. Uh, so basically, luckily, we when we were building Madara, we kept all the functionality related to StockNet within a palette called Palette StockNet. So the idea is that whenever now you want to start a new app chain that wants StockNet like blocks and it wants like Cairo contracts. So if you want to support two things, if you want your RPCs like similar to StockNet, like invoke functions, declare functions, and so on. And at the same time, you also want like Cairo contracts because like it won't make sense without that. So if you also want Cairo contracts, like the VM and Blockifier and everything, what you can do is that you can import the palette StockNet into your app chain, and you'll get all this functionality out of the box. And you don't like this literally removes all the boilerplate codes. For example, this is the Madara repo which you see right now, which has like a lot of code. We have the client, the RPCs, transaction pool, the palette itself, primitives, and so on. And the Madara node template is basically an app. It's basically a template that it's called Madara app chain template actually. So yeah, it's basically a template that you can use, and it removes all the boilerplate code. So if I go to crates right now, I only have 3 crates: the node, the runtime, and the palettes. The palette is also extra actually. This is just an additional palette that I've used to show that if you want to use something along the Starknet palette, like let's suppose if I want to use a palette in Substrate for governance or a palette for some other functionality, then this is just an example that yes, you can use other palettes along with your Starknet palette. For example, this I just copied this from Substrate's template, like do something. It's a very basic example, but otherwise, if you just need to like just change some basic configuration options, then you just need the node and the runtime. That's it, and all the other code goes within palette Starknet. So you can actually see that. I go to my cargo file. I'm importing the palette Starknet from GitHub. I think like eventually we can have this using crates.io. Like we can have our builds, which will like keep updating with the new releases. But yeah, right now I'm just importing it straight from GitHub with the release tag version. So yeah, and I'll just show you now like the main thing is like if you're making an app chain from Madara, you want to configure things. So when we were making the palette Starknet on Madara, I think we all tried to make sure that whatever parameters are configurable and which will change from one app chain to another, we kept all of them within the palette config itself, so that like it helps us later on, and it did help now. So if I go to the palette.rs files, I'll just quickly walk through the files that you will actually need to change. And overall, there are not many files as such. It's a pretty small project. So for example, like if I go to the palette.rs file, I can see all the files needed in the palette Starknet config. So here you can specify the hash that you want to use, like Pedersen, Poseidon, or like if you want to implement your own hash, then you can do that as well. You can specify if you want any transaction fees, like if you don't want your chain to have transaction fees at all, like specify disable to true. The nonce validation, the maximum number of steps you want. For example, if you want to allow contracts on your chain to have huge transactions, you can change this. And like, for example, currently Starknet allows 1 million steps in one transaction maximum. You can change that like to 10 million or whatever you like. Similar, like the maximum number of steps in a validate call, the chain ID, the recursion depth. The recursion depth is something that comes from the Cairo VM, like the maximum recursion you can do while executing any transaction. So yeah, you can set all those things in the palette config. That like, you just need to like define the values here, the actual values, and that's it. It will just work out of the box. There is the config.rs file. These are the generic runtime config that any Substrate chain has. So this, for example, if you want to change the block time, you just change this variable over here. If you want, let's suppose a 500 millisecond block time, you just make this 500, and now your chain will produce blocks every 500 milliseconds. So that's it for changing the block time. The third most important thing that you will probably need to change is the genesis. I'll just come to that quickly, but basically the command file over here is it's basically the command.rs file in Substrate is like the file that decodes your command line arguments, and then it decides what you want to do. By default, Substrate already has a lot of command line arguments that it supports. Like if you just copy something from the template, but we have, I think Oak has worked a lot on this to like have specific features, and even Greg worked on this specific thing for Genesis config. So now like come to how do you add specific contracts to your Genesis? For example, like in Starknet, you just want to probably have a UDC contract to deploy new contracts and maybe an account contract. But for example, let's say Pragma is an Oracle. So it wants all its Oracle contracts to be present at the Genesis, and so on. With every app chain, you might have different requirements. For example, Kakarot in an app chain will probably want their EVM contracts to be present in the Genesis, right? So I'll just talk how you can set up the Genesis, and it's not very complicated. So there are basically two parts. The first, and I'll show you how to fetch the Genesis from the files. You can eventually do this with the URL as well. And I think that the docs are available in the main Madara repo. There's a config dot, I think there's Genesis docs, and I think there is another docs with config. I don't know. Maybe Oak can direct you to the other docs. It's also, I've linked those docs in the README of this repo as well, so you can find it there as well. But there are two steps. First, you copy all the files from your file system. If you're using the file system option and not the URL option, so you copy all the files from your file system into a Madara folder. So the Madara folder is where we keep all our assets related to Madara. So I specify what are the files that I need with Madara, and I like for example over here in configs I have my Cairo contracts. So in Cairo 1, these are the chasm files. Otherwise, they're just the compiled files in the deprecated code. So yeah, I specify what are the files that I need. I specify the location of the files. So in the first step, all these files get copied to the Madara folder. The second thing is the Genesis file. So basically, I have a genesis.json file, which specifies three things. First, it specifies all the contracts that you want declared in the Genesis. So I specify so all these files which are set over here, they get copied into a folder called Cairo contracts. And you just specify the path to that file now, and you say that this is the class hash where you want it to be declared. So you say that, okay, I want a no validated account, which you can find over here, and this is the class hash, and so on for all the other accounts. Like this is you can find the contract here, and this is the class hash. The version is basically either Cairo 0 or Cairo 1. This is the part you specify the declared contracts. Next comes the contracts, basically the deployed contracts. So the contracts that you want to be deployed at Genesis. So you specify the class hash and the address where it's deployed. So 0x1 is a no validated account. So if I just like, for example, this is the no validated account with this class hash, which is then deployed at 0x1. So similarly, you can specify all the other deployed contracts you want. And finally, you have the storage keys. Storage keys is like, let's suppose you want to have your own fee token. So that happens over here as well. Like in the bottom, you can specify the address of your fee token. And this fee token will be deployed as well over here. You can see we deployed the fee token in contracts, and you specify in the fee token address that this is your fee token address. So in the storage slot, in the storage section, you can specify that for the fee token on this specific storage slot, this is the value you want to store. The entire idea is that you want some accounts to have the fee token when you start with, right? Like probably 0x1 or 0x2, all these accounts have a lot of the fee token or all of the fee token when you start. So you can specify those storage slots in the genesis.json file. And yeah, that's pretty much. Then we have a Genesis loader which reads this and sets up everything for you accordingly. So we have a open project right now. I mean, like it's an open in discussion, and like it'll be amazing if anyone can pick it up. The idea is just to make an easy JSON, YAML, or any configuration file that can, like read all the, but you can specify in a very easy manner what are the storage slots and what are the constructor arguments and everything, and you can create this genesis.json file. For example, this is not very readable where I say that this is the storage slot where I want this value to be there, right? If you can like figure out basically an easy way where you want to say that in this contract for this variable, I want this value to be stored, and then your code automatically, you have a script or something that will generate this JSON file for you. Similarly for constructor, like there's no way technically right now for you to specify constructor arguments. Like the only way is like you deploy the contract and then you know that these are the storage slots which will be changed because of these constructor arguments, and then you manually set those storage slots. So basically, yeah, we need an easier way to generate this genesis.json file. But with that being said, these are like literally all the changes you need to do to start your own app chain. And we did this for Pragma X. So I'll just show it like, yeah, this is me going from the Madara app chain template to the Pragma X. Like these are all the changes we did. We added the Pragma Oracle submodule because it had all the contracts. We removed the the template palette, because as I said, that's just an example. You don't really need it. Just some refactoring changes. We added our Genesis contracts, and we removed, this is just removing the palette. We changed the block time and we changed the hashing. So these are literally like all the changes we have. There are still a few things left, not in Pragma X in general, but like in general in Madara, there are a few things that we need to implement for Pragma X to be ready. But as of now, with the current Madara state, these are all the things that we had to do. This is like less than 100 lines of code, and our Pragma X chain is sort of ready. So yeah, this is basically the idea. Like make it super easy to launch app chains. And this repo is there in the Keep Starknet Strange organization. So if you just go to Madara app chain template, you will find it, and there's a README that explains the structure of the template and how you can use it as well. That's if there are any questions, then I can answer that maybe. Okay, I think yeah. Otherwise, you can just telegram me or like ask me whenever you want. But yeah, that's pretty much it. Thank you.
Thank you, Apo. Another initiative we can quickly mention is the Gomu Gomu no Gatling project. So if somebody can write it in the chat, because my Japanese is not really good. It's a solution for the benchmarking of Madara and other StarkNet sequencer. Basically, when we try to have benchmark on our repository and it came with many issues, some were linked to substrate itself, to the transaction pool behavior. There is some undetermined behavior when you just spam the transaction pool out of its mind. So it kind of data race and break potentially. But there is also another problem, which is which has to do with nonce. And the solution for both of those problems is, instead of having one account doing like thousands of transactions, is having 1,000 account doing one transaction. You have the same load of transaction on the chain, but you solve both problem at the same time for some reason we won't explain. So what we did is we removed the benchmark from Madara for now, and we started in this Gomu Gomu project. It's Adele had did a contract with some dev workshop, and there is one guy working full-time on it. He's not here today. It's Arun. Maybe you are familiar with him. He has been contributing a little bit in the ecosystem, and he's right now building this from scratch. So one outside of the fact that we will in the end have like a solid benchmarking tool, he is also the first consumer of our API outside of our integration test. So sometimes things don't work or don't work the way they should, and is giving us feedback. So it will be really great to have him like work on this, because he will actually be using Madara under like some heavy condition. So I hope it will help us find new bugs maybe, or improve our performance or the way we build this application. So that's another side project which has been spawned by Madara. Okay, is that it for today? Does people want to add some things? We're good? Okay, I will close the record, say bye.